In the previous video, we talked about the different data phases and how issues can come up in each of them. Now we will take a closer look at some of these issues. You can see the issues clearly. A 4-letter code shows which dimensions each issue belongs to. Some issues are also colored, which means they appear in more than one phase. The first phase is data creation and discovery. Here several problems can happen. The first one is awareness of data combination opportunity. Combining data from different sources can lead to more accurate and useful insights. For example, integrating traffic volume, terrain schedules, and weather data can help predict how conditions will affect fans' arrival time at the stadium and enable better travel recommendations. Timely data is very important for making systems work well together. If data is not updated often or shared in real time, it can be outdated, leading to wrong decisions. In mobility systems, delay in data can cause problems with route planning, reduce efficiency, and make integrated platforms less useful. Regular and fast data updates are needed to provide reliable and responsive smart city services. The second phase is access and storage. Data archive is about storing old or historical data that it is not used often but may be needed later for analysis or predictions. For example, past bus location or previous trips are kept in the long-term storage and only used for detailed studies or simulations. This is different from data backup, which protects current active data from damage and is done regularly. Data provisioning means collocating and sharing data in a standard formats so different systems can work together. This helps make operations more efficient and decisions better informed. For example, a local bus company in a multimodal mobility platform must provide up-to-date information on routes, schedules, and bus locations in a standard formats. Without this, the platform cannot combine bus service with other transport options like trains, bikes, or scooters, making it harder for users to plan a smooth journey. The third data phase is integration. We want to talk about some issues that happen in this phase. Duplication. Duplication happens when the same data exists in more than one system or dataset. This can cause inconsistency, waste effort, and lower data quality. For example, if a fan registers for both a club shuttle and the city public transport for a same trip, it creates duplicate entries. These duplicates can lead to the wrong estimate of field capacity, unnecessary use of resource, higher cost, and lower user satisfaction. Encoding. Some data like exact entry and exit time or travel routes is sensitive. If this data is shared across the system without proper security, such as encryption or safe storage, personal information could be exposed. For example, a scooter app that tracks the location could allow someone with the scooter ID to follow a user's movement. The next data phase is utilization. We want to talk about some issues that happen in this phase. Collaboration barriers. Working together in data interoperability is not always easy. Organizations have different goals, levels of trust, technologies, and resources. For example, on football match day in Kiel, different groups focus on different things. The transport provider wants to avoid traffic jams, private companies want to earn money, and the club wants their fans to have a good experience. They also use different data tools and formats, and some are worried about sharing personal data. All of this makes collaboration difficult. Technical resource. Many organizations still struggle to connect and exchange data because they don't have the right technical setup. This can include things like weak servers, unstable network connections, incompatible software, or limited data management tools. In Kiel, on match days, the city needs cloud servers, APIs, and experienced developer to bring all mobility data together and support fans travel planning. Without this technical resource, combining data from many sources would be very hard, and the system wouldn't work well. Now we want to talk about the issues that happen in post-processing. Metadata means information about data. It tells us things like where the data comes from, when it was created, its format, and who can access it. Good metadata help people find data, understand it, and use it correctly. For example, one company may save travel distance in miles and another in kilometers. If the metadata doesn't say which one they used, the data can be mixed up. This can lead to wrong results like incorrect trip planning or bad analysis. Schema notation are standards that help different systems understand data the same way. For example, using common structure like JSON makes sure that the company A's departure time and company B's starting time stamp are recognized as the same things. This helps combine transport data from different sources smoothly. Now we want to talk about the cross-cutting issues that happen in all data phases. In the data integration process, it is important to follow all laws and rules. For example, when collecting fan travel data, organizations must follow the EU's GDPR. This means personal information like names or contact details cannot be collected or saved without clear permission from the user. The next one is bias. Bias in data is also a big challenge for fair and effective smart mobility systems. If the data only represents certain group or if some area have a better data than others, the result can become unfair. This can harm some communities, create wrong decisions, and reduce trust in data systems. To avoid this, data collection should be diverse and transparent, so the services are fair for everyone. In this video, we learn about the issues that can appear in different phases of data interoperability. In the next video, we will look at the requirement for solution and see how they can help solve these issues.